Hey everybody, we're going to be working on example 5 and the monitoring progress question for the notes for geometry day 19. And so for this one we're going to be needing the second theorem that you should have copied for day 19, which is the areas of similar polygons. So it's this one right here, and so it's very similar to the other one from before, the perimeter, but the only thing that changes is that now, because we're looking at an area of the polygons, instead of just looking at my scale factor k, we are looking at my scale factor at k squared. Alright, so let's see what that looks like in this problem. So we have in this diagram, triangle ABC is similar to DEF. Find the area of DEF. So for this one, just like before, we want to figure out what our scale factor is first. And it doesn't matter if it's from big to small or from small to big in this case, so long as we're consistent. I'm going to make it so that my scale factor goes from little to big. So in other words, 10 over 5. Alright, so this is going to be k. 10 over 5, we know that that is just 2. And we also know that k to the second power is actually going to be the same thing as 10 over 5 to the second power, which is 2 to the second power. Okay, so according to my theorem, we know that the area of, let's see, we put the big figure on top, so this figure right here. So the area of the big figure is 36. 36 divided by the area of the small figure we don't know yet. And so because we don't know yet, we have to give it a variable name. I'm going to call it A for area. And so we know that that has to be equal to our scale factor to the second power. So then we have our scale factor to the second power is actually just 4. Right? Because then 2 to the second power is 4. So we put this like that. Now we have to cross multiply again. We're going to make this a fraction. And we're going to cross multiply to find A. We get that 4 times A is 4A. And that's equal to 36 times 1 is 36. If I divide both sides by 4 here, I'm going to get what I want, which is my area, which is 9. So now we know, thanks to theorem number 2 for areas of similar polygons, that the area of this little triangle has to be 9 centimeters squared. So once again, we need that scale factor to build this, to use the theorem. But once we find our scale factor, we should be set to go when we're solving these problems. Now for this one, monitoring progress 5, we're doing the same thing, right? In the diagram, GHJK, which is this little rectangle, is similar to element P, which is this bigger one. Find the area of element P. So just like before, we're going to find the scale factor. So scale factor, in this case, I'm going to do 7 over 21. Alright, because I know this and this are corresponding. 7 over 21 actually reduces to 1 over 3. Again, this is my k. So k to the second power, or k squared, is actually going to be 1 over 3 to the second power, or 1 to the second power is 1, 3 to the second power is 9. Cool, so we have k squared, so we have this side of the formula. Now we need this side of the formula. So let's see, over here we have little on top, big on the bottom. So we're going to do the area of the little one, which they gave it to us, was 84, divided by the area of the big one, which we don't know. So once again, I'm going to give it an A for area. And we know that that has to be equal to k squared, which we already figured out was 1 over 9. So now once again, if I cross multiply here, right down the middle, I should be finding my answer in one step, because 8 times 1 is just going to give me 8, which is what we want. And then 84 times 9, I'm going to punch that in my calculator, and we're actually going to get 756. So again, without knowing more than one side length, we were able to figure out the area of this bigger rectangle, and we know it has to be 756 meters squared.